Okay, in this video we are going to talk about Ohm's law, and effectively we have discussed Ohm's law inherently in the VI relation with the resistor or with the resistance, that I, the electric current, equal the electric potential V over the resistance of the sample. So if we have a potential difference is applied across a device being tested and the resulting current I through the device is measured, as V is varied, as the voltage is varied, both in magnitude and polarity, the current will be varied both in magnitude and polarity. So, for example, if I have the potential at this point is positive and the potential at this point is negative, or this potential is higher than this potential, then the electric current will follow from the higher potential to the lower potential, and the value of the current would be V over R. So if I increase the potential V, the current would be increased. Now, if the potential is interchanged, such that this is the positive and this is negative, so if this axis representing the value of the potential of this point, so if this is positive here, it would be negative here, so it is negative, the current will flow from this point to the other point, so it would be in the negative direction, so it would be in negative. So that's what we are seeing. A potential difference V is applied across the device being tested and the resulting current through the device is measured, as V is varied in both magnitude and polarity. The polarity of the potential V is arbitrarily taken to be positive when we are talking from left to right. When the left terminal of the device is higher potential than the right terminal, the direction of the resulting current from left to right is arbitrarily assigned as plus sign. So we will assume that if we are going from the left to the right, so the current would be positive. So if the potential of the left point is negative and the potential of the right point is positive, the current will flow from right to left, so it is negative. So the reverse polarity V with the right terminal at the higher potential is then negative, and the current in this case is assigned to by minus sign. If we draw the relation between the current and the voltage for a specific value of resistance, for example 1000 ohm, so if I'm talking about 2 volts over 1000, it would be 2 milliampere. If we are talking about 3 volts, it would be 3 milliampere. If you are talking about 1 volt, it would be 1 milliampere. If I'm talking about minus 1 volt, it would be minus 1 milliampere. Minus 2 volts, minus 2 milliampere. And minus 3 volts, minus 3 milliampere. So, in general, the curve here is linear. Its slope is 1 over R. It passes through that what we are seeing here. The IV versus V for a resistor. The plot is a straight line passing through the origin. So the ratio I over V, which is the slope of the straight line, is the same for all values of V. So the slope here is the slope here of delta I over delta V is the slope. So if we are talking about delta I over delta V, or delta I over delta V would be the same. This means that the resistance, which is V over I of the device, is independent on the magnitude and polarity of the applied potential difference. Because the slope is constant, So the resistance here or here or here or here is the same, because at any point the slope of the curve is 1 over r. So if the slope is constant, so the resistance is constant. So this means that the resistance, which is V over I of the device, is independent on the magnitude of the on the magnitude and the polarity of the applied potential. So regardless what is the value of the potential difference, the resistance is the same. This relation, what we are calling Ohm's law. Ohm's law states that the current through a device is always directly proportional to the potential difference applied to the device. A conducting device which obeys Ohm's law when the resistance of the device is independent of the magnitude and polarity of the applied potential difference. So assume that we have applied the potential from left to right or from right to left, it doesn't matter. The resistance will be the same. So this device, in this case, obeys Ohm's law. The conducting materials obeys Ohm's law when the resistivity of the material is independent of the magnitude and direction of the applied electric field. The same way, if we are talking about the material itself, not the device, if I am applying electric field from right to left, the current density will be the same as if I'm applying the same electric field from left to right. So the conducting material obeys Ohm's law when the resistivity of the material is independent of the magnitude and direction of the applied electric field. So this is what we are calling Ohm's law. Ohm's law states that the current through a device is always directly proportional to the potential difference applied to the device, regardless what is the polarity of this potential difference. And this proportionality is actually 1 over R. I is proportional to V, and the proportionality is 1 over R. So I equal V over R. As an example for a device which is not obeying Ohm's law, the p-n junction diode, for example. In p-n junction diode, if we are looking for its IV characteristic, if the real axis is a potential V, or sorry, if the horizontal axis is a potential V, and the vertical axis is the current I, we can say that, first of all, it is not linear relation. It doesn't pass through the origin, because actually it starts from the point near 1.5 volts nearly. So it depends on the polarity. So if I'm talking about positive polarity, V is positive, I have a characteristic. If I'm talking about negative voltage, I have completely different characteristic. So a plot for the IV for a conducting device, which is the p-n junction diode, current can exist in this device only when the polarity V is positive and the applied potential difference is more than 1.5 volt, because as long as the potential is less than 1.0 volt, there is no current. After 1 volt, there starts some current. When the current does exist, the relation between I and V is not linear. This is non-linear relation. Linear is something like line. It depends on the value of the applied potential difference. If it is non-linear, so it depends on the value of V. So from these characters, we can distinguish between two types of device by saying that one is obeying Ohm's law and this one doesn't obey Ohm's law. So this IV characteristic doesn't obey Ohm's law. If I'm talking about Ohm's law, I should find straight line passing through the origin. Okay?